The diagram shows an isosceles triangle ABC where AB is equal to AC equals 5. We can see that on the diagram. The arc BEC is part of the circle with its centre at A, and it's got a length of 6.2. So, in other words, this bit here is a sector. D is the midpoint of the line BC, and the arc BFC, so this bit around the outside over here, is a semicircle with its centre at D. We want to show that angle BAC is 1.24 radians. Well, we can use L equals R theta for that. And the length of the arc is 6.2, and that's going to be equal to 5 theta, which means that theta is equal to 6.2 divided by 5. So 6.2 divided by 5 is 1.24. So that was nice and easy. The perimeter of the shaded region, so we've got the arc of 6.2, and then the other arc, well, we know that that is a semicircle, and it's centered at D here. So what we'd really like to know is the length of BD, because that would give us the radius. So before I do this P equals 6.2 plus, I think perhaps we need to do a little bit of working for that. So we can work out the length of BC. Well, we know this angle, so we can use the cosine rule. So we can say, well, BC squared is going to be 5 squared plus 5 squared minus 2 times 5 times 5 times the cosine of 1.24. And we need to make sure we're in radian mode there. So I know that my calculator is actually in degree mode at the moment. Let's change. And so what have we got? We've got 5 squared, 25 plus 25. Take away 2 times 25 times cosine of 1.24. That gives me 33.76, and of course I need the square root of that. So that will be 5, so that means BC is 5.81 and so on. And so the radius is half of that. So BD. So the perimeter is going to be the 6.2 plus a half times the circumference for that semicircle. So that would be 2 times pi times the radius, which is 5.81 divided by 2. So we've got 6.2 plus, well, the half of 2 is just 1. So we're going to have pi times my last answer divided by 2. And that's 15.33. And that would be in centimeters. Okay, so now we want the area of this shaded region. Well, we always need a strategy for doing this thing, and that's a semicircle. So I'm going to have the area of that, and then I'm going to take the area of this segment. So we've got the area for the semicircle, take away the area for the segment, and that's the area of the semicircle, take away, to get the area of the segment, we'll have the area of the sector, and then take away the triangle. So that's the area of the sector, take away the area for the triangle. So for the semicircle, that's going to be pi times the 5.81 and so on, divided by 2. Squared take away, the area for the sector is just a half times 5 squared times theta, which was 1.24. And the area of the triangle, we're using a half AB sine C, so that's a half times 5 times 5 times the sine of 1.24 radians. And I probably should have stored a bit more of this answer here. I really wish I had done. So I might just do a quick recalculation of that. So I've got 25 plus 25, take away 2 times 25 times the cosine of 1.24, and we want the square root of that, and we want to divide that by 2, and that's that radius. So I've got pi times the answer squared, and oh, that was a bit of an oversight, it's only a semicircle, isn't it? So divide that by 2, and then we'll take away 0.5 times 5 squared times 1.24, take away 0.5 times 5 squared times the sine of 1.24. And that gives me 9.58. And of course that would be centimetre squared, correct to 2dp.